Okay, now we're doing the analysis, and there's a couple things you have to remember. In series, the current is the same. In parallel, the voltage is the same. Okay, and then you got to just use V equals IR and power equals IV. So, let's go back to the end where we ended up. Okay, so we know the equivalent current. So we had 24 volts here. The equivalent current was 3 amps. Okay, that means in R1, I1 is going to be 3 amps, and I8 is going to be 3 amps. That means the voltage, because V equals IR, the VEQ is going to be 24 volts, which makes sense because that's where our battery is. And V1 is going to be 18 volts, and V8 is going to be just 6 volts, which makes sense because that should have to 24 volts. So now I'm going to go back to my picture, or my grid, and I know that it was 3 amps and 18 volts in resistor 1, and then I could figure out the power. 3 times 18 is 54 watts. Okay, so now I'm going to go back and look at the rest of the circuit from the end forward. So now I know that I8, which was a combination of R2 and R7, had 6 volts, right? So that means V2 is going to be 6 volts, and V7 is going to be 6 volts. That means I7 and I2 can be figured out. Well, we know V equals IR, so I is V over R. So 6 divided by 4 is 3 over 2, or 1.5 amps. And 6 divided by 4 is 1.5 amps. So I can go back to my grid now, and I have 6 volts here, and I have 1.5 amps. And I could do, my power is 9 watts. And ultimately all my power and all my resistors should up to 72 watts. Okay, so we're getting somewhere, right? So now I have to think about, well, what was R7? R7 was a series, right? So it was a series of R5 and R6. So since R7 had 1.5 amps, I5 is going to be 1.5 amps, and I6 is going to be 1.5 amps. Okay? And that means I could do the voltage too, so V6 and V5. So I just multiply IR, and I could get those voltages. So I get V6 is 2.25 volts, and V5 is 3.75 volts. And now notice I can put in my I5, which is 1.5 amps, and I could put in my V5, which is 3.75 volts. Okay? Now, remember, I need to now do R6. Well, R5 and R6 were in series, so now I know that R6 was part of a parallel. So now, going back up to R3 and R4, they should have the same voltage. So V4 and V3 was the same voltage, which was 2.25 volts. Okay, so I know that this was 2.25 and that was 2.25. So then I could figure out my current and my power everywhere else. So now I know my current in 4 was 1.125, so 1 1/8. And in 0.375. And my power, when I calculate that, is about 0.84, 2.54, and about 5.63. And if you add all these up out to the hundredths place, you get 72 watts.